for the part 2 of this, let's talk about nodes. What is node? Nodes are the nodes is just like if we talk about the structure of orbitals, just like this p orbital, then nodes is the probability of finding the nodes is a place where probability of finding an electron is 0, just like this is the node here. The probability of finding electron is 0. All the electrons will be present in here. So this is a node. So there are two types of nodes, radial nodes and angular nodes. To calculate the radial nodes, we use a formula known as n minus l minus 1. This is the formula for calculating radial nodes, and for angular nodes the formula is L, which is. Now let's get back to the next topic which we will be studying today, that is atomic spectra. So atomic spectra has been studied by the Niels Bohr experiment. You can explain this with the Niels Bohr experiment, and it is studied in a hydrogen like species, just like lithium plus 2, beryllium plus 3. So Niels Bohr performed an experiment of electron discharge experiment, in which we place a cylindrical tube like structure and hydrogen gas is filled there. And when we perform some electric discharge and some heat or anything like that, and some energy is provided, then particular rays is observed, not a pure, just like some radiation, some 2-3 colors will be seen. So to explain this, why the color has been seen, he explained about the transfer of energy from ground state to excited state has been seen by providing an energy, and after getting excited, when they come back from excited state to ground state, they release some energy in the form of radiations and anything like that, color or anything. So this has been this experiment proves a very significant role in there. And here to calculate the energy difference between these particles, we uses a formula known as E is equal to minus 13.6 z square upon में n square, n2 square minus में minus 13.6 z square upon n1 square, to calculate the daily change in energy of two different particles. Just like by calculating this, all that, we will get particular electron volt of energy. And we know that for calculating the wavelength of these radiations or these two different particles or excited states present, we use a formula known as 1 upon lambda is equal to R, which is represented by Rydberg constant. Z square 1 upon n1 square minus 1 upon n2 square. This is the formula for calculating the wavelength of the particular hydrogen atom if electron jump from n2 to n1. And the value of this Rydberg constant is 109677 centimeter inverse, or 1 upon R value is equal to 911 angstrom. These are the values of these R. Now let's discuss about the energy levels. Just like here, ground state energy level n equal to 1, this n equal to 1. If we go from here to here, n equal to 2. n equal to 3, n equal to 4 and 5 and 6 and 7. As we go from down, energy get decreased as we go all the way from down to the top. So this is more energy and this is even less energy and this is even less. So these energy levels are not in equal level. So if we come from n2 to n1 or n3 to n1 or n4 to n1 or n5 to n1 or n6 or n7 or even from infinity to n1, this is called Lemma series. Lemma series. And if you come all the way from everywhere to n3 to n2 और n3 और इधर और ऊपर, then this is called Balmer series. Here n1 value is 1, here n1 value is 2 because the rays are coming from all the way from top to the second energy level, and this is called Partian. Then bracket, then P fund, etc. So these energy level where first line of Lemma series, here this come under these lines are come under UV region, and this line is come under visible region, and all of these come under IR region, infrared region. This is called energy level diagram for Lemma series, Balmer series, Partian series, and bracket and P fund.